Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Step 1. Identify the starting material structure. The starting material is PHCH or -CCCH is equal to CHOMe. It contains a propargylic alcohol, secondary on the carbon bearing the phenyl group, an internal alkyne, a conjugated vinyl ether terminus, CH is equal to CHOMe, and one existing C is equal to C double bond. Step 2. Reaction with H to PD BaSO4, Lindlar type conditions, semihydrogenation. PD BaSO4 is a poisoned, partially deactivated, palladium catalyst used for semihydrogenation of alkynes to CIS alkenes. Under these conditions, the alkyne, CC, is selectively reduced to a CIS Z alkene, C is equal to C. The existing vinyl ether double bond, CH is equal to CHOMe, is generally less reactive under these mild conditions and may also be hydrogenated, but the key transformation is the alkyne CIS alkene. After hydrogenation of the triple bond, product A is PHCH or CH is equal to CH is equal to CHOMe, A1, 3 diene system with the vinyl ether intact or with the enol ether present. More precisely, A is PHCH or CH is equal to CH is equal to CHOMe, a diene with a terminal vinyl ether. Step 3. Reaction of A with H3O plus acid hydrolysis. The vinyl ether group, enol ether, CH is equal to CHOMe, undergoes acid hydrolysis. An enol ether on hydrolysis gives an aldehyde or ketone. The terminus CH is equal to CHOMe hydrolyzes to CH2CHO, but since it is part of a conjugated system, the hydrolysis of the vinyl ether CH is equal to CHOMe yields CH2CHO. However, the full conjugated system PHCH or CH is equal to CH is equal to CHOMe upon acid treatment also causes dehydration of the allylic propargylic alcohol, the PHCH, or group loses off under acidic conditions to extend conjugation and hydrolyzes the vinyl ether. Step 4. Combined effect, dehydration of the alcohol and hydrolysis of the vinyl ether. The secondary benzylic allylic alcohol PHCH or readily dehydrates under acidic conditions, H3O+, to give PHCH is equal to extending conjugation. Simultaneously, the vinyl ether CH is equal to CHOMe hydrolyzes to give CH2CHO or via enol aldehyde, CHO at the terminal position. After dehydration of O and hydrolysis of OMe enol ether. Dehydration, PHCH, of PHCH is equal to, adds one double bond. The chain PHCH is equal to CHCH is equal to CHOMe after dehydration at the alcohol end becomes PHCH is equal to CHCH is equal to CHCH is equal to. Hydrolysis of vinyl ether, CH is equal to CHOMe, CHO. Putting it together, starting from PHCH, or CH is equal to CHCH is equal to CHOMe, compound A. Acid catalyzed dehydration of the benzylic alcohol gives PHCH is equal to CHCH is equal to CHCH is equal to CH. But we must track carbons carefully. Carbon count in starting material, pH, C1H, of C2C3C4H is equal to C5H-OMe, 5 carbons in chain. After semihydrogenation, pH, C1H, of C2H is equal to C3H, C4H is equal to C5H-OMe, A. Under H3O+. 1. Vinyl ether hydrolysis, C4H is equal to C5H-OMe C4H to C5O, i.e. CH2CHO, giving PHCH, of CH is equal to CH CH2-CHO initially as enol tautomer, but the enol ether C4 is equal to C5-OMe hydrolyzes to give the aldehyde at C5-CH2-CHO. 2. The allylic benzylic alcohol at C1 dehydrates, PHCH, or loses H2O. PHCH is equal to connecting into the diene. Result: PHCH is equal to CHCH is equal to CHO, which is PHCH is equal to CH2-CHO. This is option C. PHCH is equal to CH2-CHO. Why other options fail? A. Retains the OH and has 6 carbons in chain, does not account for dehydration and correct hydrolysis product. B. PHCH is equal to CHO has only 2 carbons between PH and CHO, too short, only 3 C chain versus 5 C chain. D. PHCH is equal to CH, 3, CHO would require 7 carbons, too long for the 5 carbon chain. Therefore, the correct answer is C. Therefore, the correct answer is option C.